Okay, so let's present another example out of our text. This is chapter 6, section 2, and we're looking at example 6-8. The subject of this is decibels at a concert. I have not copied it down, so we'll just go ahead and read it out loud. A decibel is a measure of the intensity of sound. Good to know. The average number of decibels at a full concert is 120. Assume that the variable is approximately normally distributed. So that's going to be our assumption that's underlying in all of these problems. We can't do anything else unless we assume that. And the standard deviation is 6. If 100 concerts are selected, approximately how many will have a decibel level less than 112? All right, so here the first thing to do is change the lighting display just a bit. All right, so the first thing to do is identify the key elements of the problem. So I've written down here mu is equal to 120. It's the average value at a full concert is 120. Standard deviation sigma equals 6. So there's no confusing those, all right? Then notice here I have two different values, 112 and 100. So it gives us a little bit of extra information. The question is a little bit different. It does not just ask us about probability in this question. So here I've determined that x is 112 because that is our decibel level. So here we're looking at this type of probability, the probability that x is less than 112. And remember, of course, we have to take the x value and convert it to a z value, and then our z cutoff score is going to be different than this x cutoff score, but they're going to be linked because that's the z that goes with that x, right? And then the idea is this: after we get that probability, to answer the question, how many do we expect out of 100 concerts, out of 100 people going to these different concerts? Um, how many will have that decibel level? Well, that is just a simple multiplication. We'll just multiply the number of concerts that we attend times the probability that they'll have less than this decibel level, and that should be the estimated number of how much we expect. That is literally our expected value, or our mean value for that probability distribution. All right, so anyhow, let's go about this. So that is our general outline. We're going to go ahead and plug in 112 in place of x, minus 120 in place of mu, divided by 6 in place of sigma. Kind of looks just like sigma. That's a 6, okay? So we have negative 8 divided by 6, and so that works out as negative 1.33, all right? So here, the probability in terms of the standardized normal distribution is the probability that our z-score is less than negative 1.33. So we'll sketch the distribution here, approximately like that. There's 0 in the middle if we're looking at the standard, and there's negative 1.33 if we're looking at the standard normal distribution. And so we want to know less, right? So quieter concerts. So that's the area that we're looking at if we are looking at the z distribution. Or, well, if we want to view it in terms of our distribution, our average is 120. This value for x would be 112, and we're still looking at the same area, right? So whether it's the probability that x is less than 112 or the probability that our z is less than negative 1.33, either way, it's the same. And now we'll go ahead and just quickly look up that percentage, that probability. So there's negative 1.33. We have a probability of 0.0918. There it is. Okay. So now we're just going to multiply that times 100 people, and that gives us, well, that would give us 9.18. All right, and we'll just go ahead and round that down because we can't have 0.18 concerts having this lower level. Let's just say there's approximately 9 concerts that are weak in terms of not being loud enough to blast your ears to smithereens. Anywho, okay, so we'll sign off with that example now.